CorelDRAW Tips and Tricks. Today's session, Introduction to Bitmaps for Sublimation, with yours truly, Steve Spence, brought to you by Condi Systems. In this session, we'll introduce the idea of using bitmaps for sublimation. Bitmaps can look like vector drawings, photographs, cartoons, or even text. First, let's learn how to properly import a bitmap into CorelDRAW. We begin by going to File, Import, select the location on your computer where the file is located, and in this case it's in a temp file, and we're going to work with this photograph right here, so we're going to select it and click Import. As soon as we do, we get this batch of information along with a right angle. It says that this is an untitled file, which is true, and that it was saved at 10 inches by 7.5 inches. That's really all the information, useful information, that it gives us at this point, and now we have a choice. We can import it, actually put it on the screen, in one of two ways. Most often we will use the click and drag method, and the click and drag method is the wrong method to use with bitmaps. Get into the habit of not using this click and drag, and the reason is this: although that picture looks pretty good on the screen, if we look at it to see what the resolution of that picture is, it is actually only 16 dpi, and that's because we used the click and drag method to import the photograph. So let's delete that, and let's go back and let's import it properly. Import, go to the file. We can just double click here if you want to. Import. There's that box with the information again, except this time, rather than click and drag, we're just going to do one left mouse click, and we'll zoom in so you can see the picture. That's one way, and that will import the picture at the highest possible resolution, or if you prefer, the resolution at which it was saved. Let's get rid of that photograph, and we're going to reduce our CorelDRAW a little bit, and we're going to go over here and we're going to look at that same temp file that holds the picture we want and learn the second way to import the photograph correctly. This is the photograph we want to collect, and so we'll just click and drag it over, and there it is. And when we look at the resolution, you see that it is 72 dpi, and that is what it was recorded at. So there are two ways of doing this. Either one is fine, but do not bring it in and click and drag. That's a bad habit, and although you can get away with it sometimes, it's really a bad habit to get started on. So let's get rid of this one, and let's start talking a little bit about how we work with these bitmaps. We're going to take that same photograph, except this one is recorded at a much higher resolution, and we're going to learn a couple of things about it. First of all, let's select the photograph, and you have the handles just like you do on any object, and you can stretch and alter it, and you can get by with that a little bit. If you have to just squeak it a little bit, that's okay. If this is just a little bit too narrow, we can get away with that. That's not going to cause a problem. But we don't want to do any more than that with our handles. Now that we've selected the piece, let's go up to Bitmaps, and let's learn about the resample. Click on Resample, and it tells us what that bitmap really is. This particular bitmap is 10 inches wide, 7.5 inches tall, and it is recorded at 300 dpi, which is perfect for sublimation. It also tells us the size of the file, and this is something you want to get in a habit of checking, because some bitmaps can grow to be enormous in disk size, and as they become larger and larger, they become more and more difficult to process in CorelDRAW. If you get too big, CorelDRAW will finally just shut down and you have to start all over. But something up to, say, 50 megabytes is typically fine in CorelDRAW. So we've learned some things about the bitmap that we're working with, and we can know that 300 dpi, this is just fine. We can print it up to 10 by 7.5 and expect to get a really nice photograph. I'm going to pull in some little black squares here and give you, if I may, a short photography lesson. This photograph was shot by a friend of mine using a very high resolution, very fancy camera that had what is called multifocal points. This becomes important when you begin working with photographs because it makes a difference how well the photograph was recorded originally. You can rarely improve on a photograph. If it was imported, it's out of focus, it looks lousy. You might learn how to doctor it a little bit, but basically if you get a lousy photograph to start with, you're going to end up with a lousy photograph. In this case, he was interested in showing the snow, and he didn't do something that I think is critical. Here's what he did. He shot this picture using the multiple focus points in his camera. His particular camera has 8 of these, and they're indicated by these black squares. What the camera does is automatically it focuses each one of these 8 squares so that it is perfectly focused. And then it takes an average of all 8 of them, and that's where the focus is. Now what happens with this is, although it looks like a pretty good picture, nothing in this picture is actually in focus. Nothing. If we look at the sign, it's not focused. If we look at the edge of this shed, it's not focused. If we look at the edge of this picnic table, it's out of focus. So although this looks like a really nice picture, it limits somewhat what we can do. If we wanted to crop the picture, that is, cut out everything except this center area, it probably wouldn't work very well because he didn't focus on the sign. Whatever we enlarge, whatever we focus on in working with bitmaps really depends on the original quality of the picture. Now there are a couple of things that we'll throw in here just so you'll know. When we talk about resolution, we use the phrase DPI. Ideally, anything we sublimate is at least 300 DPI. Now, sometimes we can squeak on that a little bit, and if you drop down to 250, it isn't going to end the world. But for hard goods, like MDF board, fiberglass reinforced plastic, metal, anything that's hard, it really should be sublimated at 300 dpi, or as close as you can get to it. Now we can squeak a little more with soft goods, t-shirts, flags, and that kind of thing. You can drop down to 250, even 200, and it's still going to look good because the surface is already porous. Still, I always try sublimate at 300 dpi. Okay, let's take an imported image and let's learn how to work with it. Let's use this image right here. This is a professionally shot image It's used by Condi in their advertising. Now you'll notice that it looks really good. As we zoom in on it, you'll find that it begins to fall apart a little bit. These are pixels, and that's what makes up an image. When we talk about DPI, or dots per inch, we're really referring to printer technology. Printers work by squirting little dots of ink onto a piece of paper, and those dots in an ideal world are round. But on the computer monitor, they're square, and they're referred to as pixels. Each pixel is the equivalent of one dot. Now, let's see if I can help you understand just a little bit more. If I've already made this terribly confusing, let's see what I can do to make it even more confusing. I'm going to take a little square here that I have already drawn, and this square is 1 inch by 1 inch. And then I'm going to take this photograph, and I'm going to go up here and look at the resampling, and I can see that it's 300 DPI, and the photograph itself is 6 by 4.5. So we'll zoom in, and we're going to look at the pixels in this particular photograph. We can take our box and place it anywhere we want to. It doesn't make any difference. And then we're going to zoom in on the box. And as we continue to zoom in, we'll begin to see pixels. You can see some of them up here. Let's zoom in some more. Now we're really beginning to see them. See these squares? Those are pixels, each one. And when we zoom in too much, the picture really goes away, and all we see are those little square pixels. Now, if we were to count those pixels for 1 inch, there would be 300 of them going left to right, and 300 going up and down. That makes it 300 DPI. It's simple when you know what's going on. If we have a photograph that comes from the internet, it might be as low as 72 DPI. The common resolutions that come off of the internet are either 72 or 92. Both of them are inadequate for use in sublimation. They need a lot of doctoring in order to work. In this case, you can see that you could zoom in on this picture and take out any part of it and still come up with a fairly decent picture. We can begin to see some pixelization around the handle. We can see some pixelization along this straight edge. And that's always where pixelization shows up first, around edges. If we zoom out just a little bit, it begins to look better and better and better. That's resolution. Now let's import an image from the internet. This image is actually pretty good. It was recorded only at 96, if I remember right. We'll resample. 72, I'm wrong. This was recorded at 72 DPI. And as you can see, it doesn't look too bad. You can see, you can see some of the pixelization beginning to occur around the bat. But if this is printed on something really small, it's not too bad. To give you an idea, we can resample this and make it look a lot better. Let's take the image. Let's go into Bitmaps, resample. This was drawn at 3 inches. Let's take it to 1 inch. And as we take it to 1 inch, we can also increase the resolution by 3 times. 3 times because we're going from 3 inches to 1 inch. So 3 times is about 210. So we'll put it in at 250. That's close enough. And we'll take another look at what we've got. And you see now it has smoothed up the bat. That's not because we've improved the photograph, it's only because we've reduced the size of the photograph, which gives the illusion of having a higher resolution. Let's zoom back out and let's look at another photograph. This also came from the internet. There we go. And you can see it's very small on my screen, and the reason it's small is because it's an absolutely horrible logo. It is so pixelated that it would be unusable in any form in Sublimation. And in this case, no matter what you did, it would not work. It would just look terrible. This is a real customer of mine. This is what they sent me to use to print a banner. A 3 by 8 foot banner with their logo. Needless to say, the only solution here was either them providing a better logo, which they could not do, or my completely redrawing it and starting all over with not a bitmap, but a vector drawing. What is a vector drawing? Let's go up and look at our airplane up here. This is a vector drawing. Now we can turn it into a bitmap. We can do a lot of things with it. But as it stands here, it is a vector drawing. The beauty of a vector drawing is you can make it any size you want and it will not pixelize. You can also take it apart. I'll select the drawing, go to Ungroup, and now I can select the windows. Select the windows or the doors or parts of the engines one area at a time. Move them, change the color of them, whatever it is that I might want to do. This is a vector drawing or a line drawing. And line drawings often look like bitmaps, but they aren't. And the beauty of the line drawing is that it can be enlarged or reduced in most cases to just about any size you want without damaging or deleting the quality of the image. If I wanted to make this a bitmap, I would select the entire thing, go to Bitmaps, convert to bitmaps. It gives me several options. The only one you have to really watch for is you want it to be 300 DPI at the size you're going to use it, and you want it to be RGB. You have a number of choices. The default is always CMYK. You want it to be RGB. Everything we do in Sublimation is RGB. Click OK. Once we clicked OK, you can see that it changed the quality of the lines. The lines are still pretty much there, but you see we have some dropout. You also have some shadowing in here. That's because it's a bitmap. Bitmaps are not as high resolution as a vector drawing. Vector drawings are always preferred when working with Sublimation. They just usually or very often aren't available. Let's go back out. So as we look at bitmaps, one of the things that we have to remember is that we must be very careful about trying to enlarge our bitmaps. Even reducing them must be done properly. Let's look at this bitmap again. Remember, this bitmap was 300 DPI. It was 8 by 7.5 inches, and now we want to reduce it. So we grab the thing and we just reduce it. Right? Wrong. Let's undo that and let's do it properly. We will go to Bitmaps, Resample, and now we can change it any way we want. If we want it to be 4 inches, it will automatically, of course, keep the proportion, and we can set or change the resolution, and we want it to stay at 300. So we've reduced the file size from 19 to only 3 megabytes, and if we do that, there you are. That will be a high quality image that you can sublimate. Let's undo that, and now let's enlarge it. Enlarging it is an entirely different animal. On the screen it looks like it works perfectly. It doesn't always. Let's say we want to double the size of this. We'll take it to 20 inches and we're going to leave it at 300 dpi. It will think about it a minute, and there it's increased it. Now looking at the sign, you can tell that the quality of the image is still very good. But you need to understand what happened in that image. The information needed to take it to a 20-inch image really was not there. So the computer had to create it. It had to look at each pixel, and then using a logarithm, it changed the look of the image. Let's take this little box as our illustration. Here we have 3 pixels side by side. We're going to take the first pixel and we're going to make it dark green. We're going to take the third one and we're going to make it a brighter green. Now what the computer does when it tries to do this enlargement, which is sometimes referred to as a digital enlargement, is it looks at the new pixel and it looks at all the pixels around it, not just 2, but all the pixels around it, and it says to itself, if I were that pixel, what color would I be? And it decides mathematically that that's the color it would be. Some variation between the two, left and right, and top to bottom. Now as you can see, this is a very dubious way of enlarging photographs. If you want a high quality sublimated photograph, this is not the way to get it. It is, however, a fantastic tool that if you start with a good photograph, you can cheat and you can enlarge it somewhat and still have a nice photograph and still be working with 300 dpi, even though a portion of that 300 dpi is artificially manipulated. Now let's look at one other thing before we close, and that is the horrid bounding box. Here is a piece of clip art we've imported. It is actually a bitmap, although it looks like a piece of clip art. And the bounding box, if you're not familiar, let me get a hold of it. The bounding box is a white box that surrounds virtually all bitmaps. And as you can see, when you try to lay it over top of another photograph, you've got serious problems. Now you can lay things over top of the white box, but it can't be the other way around. And if you're working with multiple bitmaps, it becomes just almost impossible. There are ways to get rid of it, but they are pretty complicated. The best way I know of, especially with a rectangular picture like this one, to get rid of something is to use power clip. We can draw a box around what we want, get rid of the black stuff, then we can go in effects, power clip, place inside frame, place inside frame, and we can get rid of a lot of stuff. But you notice the bounding box is still there. We've disguised it by making it look like a picture, but it's still there. To actually mask out the image is a much different and much more involved process, and in a later tutorial I'll show you how to do that. But for now, that's an introduction into bitmaps as we use them for sublimation. Hope you found it helpful. I'm Steve. Good luck.